All right, welcome back. This is the last section before we take a quiz on Chapter 2. We're jumping into Section 2.6. 2.6 is proving angles are congruent. So, proving angles are congruent. Okay. So even though that is the major part of what we're going to be doing, that's the whole first part, we're also just going to be doing more basic proofs. So with the start thinking part, what I want you guys to do is actually, I'm going to white this out. I want you to redraw this. So let's say we had this was 2x and this was 100 degrees. How would we do this? This was from chapter 1. Well, we know these things are congruent. So we could say 2x equals 100. Divide by 2, and you get x equals 50. Now, there was a reason we were able to do that, and that was the vertical angles theorem. The vertical angles theorem, we've already talked about this. This just says vertical angles are congruent. Now, we just stated that before, but we never proved it because we didn't know how to prove things yet. Now what we're going to do is actually prove things that we're using. In math, almost everything is proved. Okay, I know we had postulates and things that we just assumed were true, but for the most part, especially with theorems, we are going to be proving them whenever we possibly can. So, here we go. Now, going off on a little tangent really quickly, think about if we had that with every other subject you guys studied. If everything in science had to be 100% proven to be true to be able to be put into your science book or something like that. Math is amazing because everything has been proven to be true. Now, most of the proofs that we just did in the last section were like little baby step proofs. Only at the end did we actually work on geometry proofs. Before that, we were just doing math and justifying it. Now we're going to actually be working on more legit proofs. So what we're going to do now is we are going to prove the vertical angles theorem. Now we know that 1 and 3 by definition, 1 and 3 are vertical angles. Okay? We're going to show that 1 must be congruent to 3. So let's run through this process. How do I know that 1 is congruent, or 1 and 3 are vertical angles? It's just given. Okay. Now what I want to do is it says 1 and 2 are supplementary. How do we know that 1 and 2 are sup and that 2 and 3 are sup? They come together to make something like this. What do we call the little angles that come together to make a line? Linear pairs. Well, we know linear pairs are supplementary. Just something we know. Here's a postulate. Now, if that's true, then how do we know that 1 plus 2 equals 180 and 2 plus 3 equals 180? That's just definition of supplementary. Now here, this is kind of cool. Why in the world do we care that one thing equals 180 and the other thing equals 180? Well, if we know something equals 180, we'll be able to erase the 180 and we'll be able to write what 180 equals. What do we call it where you can erase something and write what it equals? Substitution. Now, when we're at this step right here, 1 plus 2 equals 2 plus 3. How did they get from here to here? What happened? It looks like they subtracted measure of angle 2 from the left and from the right. Why are you allowed to subtract something from the left as long as you subtract it from the right? Subtraction, property of equality. And lastly, if you know the measures are equal, how do you know they're congruent? Def of congruence. We just went through a process of linking 1 and 2 together to make 180, 2 and 3 together to make 180, then setting them equal to one another, then subtracting something from both sides, and then ending up with what we want. This was a process of going from something we didn't know, using tools that we've already developed, to get something we did want, to show that 1 and 3 are congruent. Now, if we ended up having measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4, that would have been a dead end. Why? Well, most likely would have been a dead end because there's nothing you can subtract away from both sides, because there's nothing in common on both sides. So that was the vertical angles theorem being proved. Given linear pairs are supplementary, not definition of linear pairs, just that they're supplementary, definition of supplementary, substitution, subtraction property of equality, and definition of congruence. You are going to be expected to be able to reproduce that at some point. So let's go ahead and run through more here. As I said, the givens are just fantastic because you can just look right up here. The only issue is sometimes there's more than one given. You need to know which one they're talking about. But on this one, it's easy. There's only one. This given must be angle 1 is congruent to angle 4. Now let's start going through this. How do we know that 4 is congruent to 2? How do we know that 4 is congruent to 2? Vertical angles theorem. Next, how do we know that 1 is congruent to 2 then? Well, it's not a standalone thing, so it must have to do with the stuff that happened above. 1 is to 4 and 4 is to 2. 1 is to 4 and 4 is to 2, so 1 is to 2. Do you remember which one it was? Where it was 1 is connected to 4, 4 is connected to 2, so 1 is connected to 2. Which one was that? Choo-choo, chugga-chugga-chugga. Which one, what property was that? Transitive prop. What you guys will notice with proofs is sometimes they're standalone things. Like this one was just the vertical angles theorem. That was easy. But sometimes it's not easy and you have to look at the steps that happened above to justify what's happening. Next, 1 is congruent to 3. Why is 1 congruent to 3? Is that a standalone or does it have to do with steps above? Why is 1 congruent to 3? Vertical angles theorem. Lastly, the transitive property. Let's try to imagine what they're saying. 2 is to 1 and 1 is to 3. So what do you think they're going to say? 2 is connected to 1 and 1 is connected to 3. So what do you think it's going to be? Well, the last step is going to be what we're trying to prove. Angle 2 is congruent to angle 3. So at this point in your ability to do proofs, it's going to be a fill in the blank, unless it's just a basic, like you're doing math and justifying it. So here, two questions you ask. Is it standalone? Is it standalone like vertical angles theorem or reflexive property or something like that? Or does it have to do with stuff above? For example, this one was not a standalone. It had to do with the stuff that happened above. Let's move on. Okay, on this one, it says, look at the figure to the right. Notice that 4 and 5 are complementary and 5 and 6 are complementary. What can you conclude about 2 and 6? Okay, let's say this was 40 and these were complementary, then that one would be 50. Those are complementary. And if these ones are also complementary, if that one was 50, then that was 40. So what do you notice about two angles that are complementary to the same angle? They must be, if two angles are complementary to the same angle, then the two angles must be congruent. Okay, so once again, if you had one angle that both of them were going to be complementary to, not complement, that doesn't make sense. Both angles are complementary to that. Well, the first angle, if it's complementary to this, then it must be 80 degrees, because 80 plus 10 equals 90. The other one, if it's complementary, must also be 80. So what do you know about these ones? They're congruent. So that's what this theorem says. This, a lot of times they call it the complements theorem, congruent complements theorem. Now we have a different one. This is talking about angles being, let me white this little puppy out here. Drew this wrong, sorry. So this would be if you had two let's do that. If you had two angles that were supplementary to the same angle. So these two angles come together to make 180, and these two angles. What do you notice about any two angles that are supplementary to the same angle? Take a look at them. What do you notice? They must be congruent. This one is called the congruent supplements theorem. Any two angles that are supplementary to the same angle must be congruent. There's no such thing as a transitive property of supplementary angles. Be careful with that. Okay, let's go ahead and do a proof on this. So, we want to show that if 1 is congruent to 2 and 3 is also, sorry, if 1 and 2 are supplementary and 3 and 2 are also supplementary, then 1 must be congruent to 2. And we're going to make a 2-column proof. So let's do this. Angle 1 and angle 2 are sub. Also, angle 2 and angle 3 are sub. How do we know that? It's just given. After I say they're supplementary, then we know measure of angle 1 plus measure of angle 2 equals how many degrees? 180. Measure of angle 2 plus measure of angle 3 is how many degrees? 180. That's just definition of sub. Think back to our proof for the vertical angle theorem. Why in the world would we ever want two things to equal 180? Because we can use substitution to show that they are equal to one another. This could also be transitive property. This stuff is to 180, 180 is to this stuff. So measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Substitution or transitive property. Did we come to a dead end, or is there something we can do here? 1 plus 2 equals 2 plus 3. Is there anything that they have on, and hang on, I need to check something out here. 1 and 2, 2 and 3. This was actually supposed to say, sorry, 1 is congruent to 3. Okay, what can I do? I can subtract that away on the left as long as I subtract it away on the right. So measure of angle 1 equals measure of angle 3. Subtraction, property of equality. And lastly, angle 1 must be congruent to angle 3. Definition of congruence. There we go. 1 and 2 are supplementary and 3 and 2 are supplementary, then 1 has got to be congruent to 3. We just proved the theorem. We went through the process of saying they're supplementary, saying they equal 180, therefore they equal one another, and luckily I was able to subtract the same thing from both sides, and we are able to do the whole thing. All right, let's see what else we got here. Okay, last page. Okay, so other theorems. Here's another thing that you're going to think is silly, but that's okay. We're actually going to use it sometimes. And that is all right angles are what? What do you think is true? They're all 90 degrees. So therefore, they're all, we don't use that much this chapter, but we'll use it in future chapters. All right angles are congruent. If we wanted to do a proof for this, we'd say this. Angle 1 and angle 2 are right. How do I know that? It's given. If that's true, then the measure of angle 1 equals how many degrees? 90. Measure of angle 2 equals how many degrees? 90. By definition of right. Why in the world would we want them both to equal 90? Because then I could say measure of 1 equals measure of angle 2. Reason? You can either think of it as erasing the 90 and putting it what 90 equals, so substitution, or if 1 is to 90 and 90 is to 2, then 1 is to 2. Transitive. Okay, either one of those. The only time you have to say transitive, if I said 1 equals 2, 2 equals 3, 3 equals 4, then 1 equals 4, too much stuff is happening to call that substitution. That one would have to be transitive. Okay? Let's see what other theorems we have up our sleeves that we're going to use later on. Congruent and supplementary angles. If two angles are both congruent and supplementary, then they have to be what? Think about this. If 1 plus 2 equals, or measure of angle 1 plus measure of angle 2, I shall actually rewrite it just so that it's not ugly. If we know that measure of angle 1 plus measure of angle 2 equals 180, and measure of angle 1 equals measure of angle 2 because they're congruent, what is the only way they can add to be 180 and be congruent? They must both be how many degrees? 90 degrees or right angles. All right, groovy. Got one last thing here. If you knew that 1 and 2 are supplementary and 1 and 4 are supplements, and measure of angle 2 is 45 degrees, prove that measure of angle 4 equals 45 degrees. Once again, a proof I would not expect you to be able to do on your own. But filling in the blank, I think, is a small enough baby step. So let's go ahead and do a baby step here. How do I know that 1 and 2 are supplements and 1 and 4 are supplements? How do we know that 1 and 2 are supplements and 1 and 4 are supplements? Given. Now, what do we know if 2 is supplementary to 1 and 4 is also supplementary to 1? How is the only way that 2 can be supplementary to 1 and 4 is supplementary to 1? The congruent supplements theorem says that these angles must be congruent. Angle 2 must be congruent to angle 4. If they're congruent, how do we know their measures are equal? If you're ever going from they're congruent to they're equal or they're congruent, it is just definition of congruence. Next, how do I know that measure of angle 2 is 45? Is that a standalone, or does it have to do with the stuff above? Oh, look at that. It's another freebie given. And then lastly, what am I going to do? Here is a 2. I know 2 equals 45. How can I just erase that and put in a 45? Substitution. So we can go to measure of angle 4 equals 45 degrees. The book gets a little sloppy here because technically it should be 45 equals measure of angle 4, and then we'd have to switch it using symmetric property, but the book is just being sloppy and does that together. So what is the most important thing from this? It is that we were able to do more It was that we were able to do more proofs, and that we learned that sometimes we have standalone parts of proofs, and sometimes it has to do with steps above. Okay, so you kind of just have to think through it. A lot of times you're going to go over and have two things equaling a number, and the reason you would do that is so that you can set them equal to one another and hope that you could cancel something out on both sides. So, once again, this was just proving that vertical angles were congruent and also doing more proofs. So hopefully that made sense. You could always rewind and rewatch this if you need some extra help. But there you go. Introduction to proofs.